Hey, everybody. I think we're going to get this party started. I'm going to introduce myself. This is me, Evil Trout. I think I'm the only person in the JavaScript community who's represented by a cartoon fish. But if there's any others, please let me know so that I can murder them. Does anybody know who this guy is? Nobody? Stephen King. So I guess this is a little bit of an unusual thing to see at a tech conference, but he wrote this book called On Writing, A Memoir of a Craft. And I'm just going to read you a couple quotes because I think it's really fascinating stuff. Because this is actually him talking about reading. So Stephen King says, "We read to experience the mediocre and the outright rotten. Such experience helps us to recognize those things when they begin to creep into our own work and to steer clear of them. We also read in order to measure ourselves against the good and the great, to get a sense of all that can be done, and in order to experience different styles." And then he goes on to say, and I think this part is really interesting, that when I read Ray Bradbury as a kid, I wrote like Ray Bradbury. Everything green and wondrous and seen through the lens smeared with the grease of nostalgia. When I read James M. Cain, everything I wrote came out clipped and stripped and hard-boiled. When I read Lovecraft, my prose became luxurious and Byzantine. I wrote stories in my teenage years where all these styles merged, creating a kind of hilarious stew. This sort of stylistic blending is a necessary part of developing one's own style, but it doesn't occur in a vacuum. You have to read widely, constantly refining and redefining your own work as you do so. So you might be wondering, well, what does this have to do at a tech conference? But I think a lot of what he's saying about reading here applies to code. I find that as I work with something like a framework or a library or an API, and I experience how they approach problems, that when I start to write code, I start to write in the same patterns that they use. I think there's this kind of idea, like, one of the worst things you can say to a programmer is like, our documentation is the code. You know, like, you should be reading proper documentation. But it's also impossible to program without reading. You have to read APIs. You can't learn something unless you read how it's done. So this talk is about reading and learning and two open source projects. One that I work for is called Discourse. The other one is Ember.js. Has anybody here heard of Discourse before? Curious? Oh, a bunch. For those who haven't, Discourse is forum software. It is designed for people who, well, I think a lot of communication on the internet these days is too focused on the short form. So if you go to Twitter or Facebook or even text messaging, you might find that it's really difficult to have a long form conversation because you're talking in 140 characters at a time. If you've ever tried to have an argument on Twitter, for example, it's extremely difficult because you can't even keep track of what people are talking about and how things are going. So I think even though short form communication is kind of one in terms of ease of use, it's left behind a lot of really good kinds of discussion. And Discourse is, by embracing forum software or trying to bring it into the modern age, the idea is, let's allow people to use paragraphs. Let's communicate in long form. Let's have quoting and stuff like that. So Discourse is 100% open source software. You can download it today. You can see how it works. We think that this is really important for discussion stuff because what we've seen these days with Facebook and stuff like that is that you have these central authorities and all communication is kind of moving into these little boxed things. You can't take your data with you when you go. You have to abide by their rules. If there's something you want to talk about that they disagree about, you can't do it. So we thought it was really important that you be able to install your own forum on your own server. And to do that, we made it open source. So a little bit about the project. It was started by myself and Jeff Atwood, Coding Horror, formerly of Stack Overflow. If you saw Joel's excellent keynote this morning, he talked a lot about what Stack Overflow doesn't let you do. And in many ways, Discourse is kind of a product that lets you do those things. So it's not about answering a question. It's about things like, who is your favorite X-Men? You know, something like that would never fly on Stack Overflow, but on Discourse, we love that kind of thing. It's, yeah, ultimately, you're not going to come to a consensus, but people enjoy discussing their interests, and it's not always about finding a discrete answer. So it kind of complements Stack Overflow in that way, because it provides an area for discussion of the things that it does not allow. The source is 100% on GitHub, as I mentioned, and we launched just over a year ago. We had a very successful first year. We were featured in GitHub's State of the Octaverse. We were one of the top 5 projects for Momentum based on their starring stuff. Also, we just recently surpassed 10,000 stars, which I'm really happy about. And we had, I don't know if it was 300, I want to say 300 unique contributors in our first year. So it's been a very successful project. But I want to talk about structure first. And in particular, I want to talk about learning and how I learned about structure from using Ember and how that helped us make Discourse a better project. But first, I want to take a step back and talk about a story of failure. I think that, people are usually known for their successes, but I think their failures contribute to their who they are just as much. If not, people tend to have many more failures than they have successes. You often have 9 and then 1. Or worse, you have 1 success and then 9 failures. So I think it's really important to sometimes look back at what you did that didn't work in order to know what would work in the future. So I once worked on a project that was really heavy on jQuery. We had a startup. We had a really, this is actually the project I worked on right before Discourse, and we had a really smart team in Toronto. And we kind of we were working on this awesome idea that we were all super excited about. I think everybody on the team was very talented. And we all came to it with these lofty expectations for how our application was going to work. We knew that we wanted an application that looked good and responded well and just looked like the total epitome of a modern application. And to do that at the time, we used jQuery. jQuery is something that I assume most developers here are familiar with because it's essentially ubiquitous at this point. And we did what we thought were essentially best practices. We made our jQuery code into modules, that were objects, and we isolated all our functions. We prefixed our variables with $signs. We basically we took everything that we did in jQuery projects in the past, and we applied it to this large monolithic code base that just grew and grew and grew with complexity as time went on. But like I said, it failed. And this was quite a blow to us. When I say failure, I'll get into that in detail, but it was really demoralizing to realize that we had even though we did what we thought was the best, we ended up creating something that didn't work. So there's a few reasons why. The first is that we mixed content and presentation. And I think this is something that's very typical of a jQuery application, is that what you'll often have is, because jQuery is really good at performing selectors on the DOM and putting data in there, what you end up doing is using the DOM as a source of truth. So, for example, let's say you have a list of items, like product IDs, or here's the list of products, and you have a delete link. Generally, what you do is use a data attribute that says, this link has ID this. Or maybe you want to output an alert message, so you then say data title. And every time you click on the link, you have to look into those data attributes to do things. And what ends up happening is you have this just weird kind of world where, it actually seems crazy to me that the way you're presenting your data is actually the place that the data is stored. If you've ever done graphics programming or game programming, I think this is if you're making Pac-Man and you had to look in the video memory to see if there's a wall there. That's ridiculous. You wouldn't do that. The second problem is that we ended up with random coding patterns. Now, I said earlier that we followed what we thought were best practices, but it turns out that what that is varied from developer to developer. We had a game plan that we agreed with, but as we went along, there was, I think, 2 or 3 front-end developers. We found late into the project that we had established 2 or 3 ways of doing the same thing. Now, I chose this slide because I think it's one thing that I want to note here is that they were more or less equivalent. None of these colors or patterns were worse than any other. And on their own, they were pretty good, but we were doing the same thing in multiple ways. And this had consequences. One of the consequences was that it was really difficult to maintain. Because when you have a hodgepodge of coding patterns and your content mixed with your presentation and stuff like that, it basically meant that features took a lot longer to implement. The features that we did have were much more brittle and took a lot more QA. I think that guy in the back driving, I think he's the QA guy. And he has to like look through this project, and it just became extremely tedious. And the last thing you want is your manager or your product manager or whoever's maybe driving the feature set saying like, why is this feature taking twice as long as the last one? It seems equivalent. And I think this is the biggest problem of all, is that it just wasn't fun. We were able to work on the application, and we did actually get a lot of compliments from it. We got a lot of people saying like, oh, this is beautiful, and it works really well, but like it was a nightmare to work with. And it was really amazing is that we had come from this great team and resulted in something just so tedious to work on. I think fun is one of the greatest motivators you can have as a developer. If you are excited about what you're working on, you can come into work and you can just plow through it. But the opposite is also true. When it's not fun, it's just everything becomes a struggle. So how do we get here? This is what I was saying. Like, how did a smart team fail? How did we follow what Hacker News told us to do and it didn't work? I don't know. And it was really, really humbling, and it was really difficult to come to grips with. And I think the major thing that I learned from this failure was that, well, in retrospect, everything's easy, but we weren't unique snowflakes. And I think that we were approaching a problem domain, and this was like a public data application. And we thought that we were really unique in this space. And I think the product was pretty unique in this space. But I think no matter what you're working on, and I hope it's unique, something like whether it's in the travel sector or gaming or whatever you're into or whatever you're working on, I hope you're working on something at least somewhat unique or a unique take on it. But it's important to recognize that probably the majority of the work you're doing is very similar to other people. And I don't actually mean that in a bad way. I mean, like, if you're building a web application in particular, you're going to have URLs. You're going to have links. You're going to have things that update on clicks. That vocabulary and grammar is really key to providing your application experience. And it's important to not try and do it all yourself. So one thing that we looked at was, on the server side, our application was Ruby on Rails. And it didn't suffer all the same problems that the jQuery application on the front did. Part of that is that I think, well, I don't know if Rails has been around longer than jQuery, I think, or at least in the public eye. But there was something about that code. Like, it was organized. We knew where our models went and our ORM, our message queue. It was just everything was where it expected to be. And it was much more fun to work at and had none of the problems at the front end. And I think it's because Rails recognizes that your application you are not a unique snowflake. You will probably want the following things. You'll probably want some kind of MVC structure. You want an ORM. You want all this stuff. And it brings it to the table. And that's what I mean when I talk about structure. I mean knowing where things go and knowing how to be productive as a result of that. So Ember. What is Ember.js? Ember.js describes itself as a framework for building ambitious applications. But one thing that I think it does is it has that same set of philosophies that Rails has on the server side about convention over configuration and about the common tool set and that approach that you are not the unique snowflake. And it applies that to building JavaScript applications. So it's a framework. It has an object model. It has a router. It has its own persistence framework called Ember Data. It has bindings, and it has a wonderful view layer and tons of great stuff, like an awesome toolkit that you can use to build JavaScript applications. But to me, the thing that appealed to me the most from day one was that I was like, oh, this is a good way to build an application. They've thought this through. You should name your file this, or you should name your class that. And if you name it that, it automatically works. This shouldn't actually come as a surprise because one of the core members or core founders of Ember is Yehuda Katz, who worked on Rails 3. And I think, so this is like, he took what he saw working in the Rails world and applied it to the JavaScript world. Now, having said that, you don't have to be a Rails developer or a Ruby developer to use Ember.js. It works with any backend. I recently did a code review with Rob Connery, and he built a .NET application. It worked extremely well. But yeah, so like I keep saying this word, but it all comes back to structure. And I think Ember says you will probably need this, so we provide that, just the same way Rails did. So you might be wondering, well, there's actually a lot of front-end MVC frameworks. There's actually way more than I could fit in this slide, but here I think are the 5 biggest ones. I apologize if I missed your favorite, but and they all offer some structure too. So like I commonly get asked, well, like, so I get it. Ember provides this, but doesn't Angular, doesn't Backbone, Batman.js. So I was thinking about complexity and how much structure something provides, and if there is a good way to illustrate this. And I don't think there is. What I have here in this graph, this is probably impossible to guess what this represents. But this is actually the number of files you need to output hello world using these various frameworks. So in PHP, you can just have hello world.php. It's like one line, you get hello world. Sinatra, the Ruby framework, the lightweight way of doing web services and stuff, it isn't much more complicated. You can have like a hello.rb, 4 lines, and then you get it. Now Rails, out of the box, gives you 19 files to do the exact same thing. That actually seems a bit ridiculous at first. So I should point out that not all those files are required. Like a lot of those you can remove, and the majority of those are auto-generated. So it's not like when you sit down with a new directory, you have to sit there and be like, oh, I missed file 17. Like it doesn't actually work that way in practice. But what Rails is giving you is a foundation for building a larger app, whereas PHP or Sinatra don't provide that. So this graph is a little unscientific. And by a little, I mean a lot. Like I kind of made this up. But I think this is true. And I'd love to hear, after I'm done talking, anyone who disagrees. But I think essentially there's this kind of, there's this graph of what I think is essentially complexity or learning required. So jQuery is on one side of the spectrum, and it doesn't actually require much learning. I mean, there's a lot to it, but to get started, if you just want to make, when you click on a link, something happens, it's not hard to just bind that event in jQuery and have, update the DOM. Backbone is a little more complicated, but Backbone's awesome in that it's like, it's a great piece of software, because it's like, I think it's like 1,000 lines long, I could be mistaken, but you can read it in an afternoon and just understand the full breadth of what Backbone gives you. But of course, when your whole framework is 1,000 lines of code, it doesn't do everything for you. So you actually have to hand roll a lot. Like you have to, I don't think it comes with a router. You have to, the view structure, you have to call render a lot. It's a really bare bones thing. Angular and Ember, on the other end, offer a lot more out of the box. And it'd actually be interesting, I was thinking to plot file size, because Backbone, it would probably almost go ascending. I guess jQuery, you can choose what bits you want. But Angular offers a lot more. It gives you a router, it gives you a bindings framework, it has an awesome dependency injection thing with it, so it's really cool. And then on the other end, you have Ember. I think Ember comes with the most, and it offers the most structure, but that comes at a cost. And I love this GIF, by the way. I posted this on Facebook recently. I was like, because a lot of I don't know if this happens to you guys, but a lot of my friends are like, what do you do all day? I'm like, you just sit, I know you sit in front of the computer. I'm like, I think this image better illustrates what I do all day than anything I could tell you. So I get it. Like when you see that learning required thing, like, you don't always want to learn. And I understand that because like your time is valuable. And it's also like, maybe you work all day. The last thing you want to do is come home, like unless you're lucky enough that your job allows you to do a lot of learning on the job. But you might be tired, and you come home, and after you've made dinner, you're like, the last thing I want to do is spend hours learning a new framework or something like that. And I get it. I respect that. But I think sometimes, and actually often, there is an upside to learning. And I think I see this a lot, like in the JavaScript world, that a lot of people are just kind of like, oh, if the amount of lines of your software product or your library exceed X, well, then I don't even care. Because if it's that complicated, then I don't want to do it. It should all be about small pieces that fit together. But there's some problems, like a bunch of classes of problems, that can only be solved with, I think, a larger piece of software. And having said that, I also think there's a benefit. And again, totally unscientific. So like, before you yell at me, I think the benefit of learning a lot in advance is that it allows you to become more productive as a developer. I've certainly found myself more productive as a Rails developer versus PHP and stuff like that once I've found where things go and what they're called. And I think the same thing is true for these ones. Definitely, like, in terms of, if you want to get started fast, jQuery or Backbone are probably really great. But if you want to build up a large application from these smaller pieces into something bigger, I think you're actually going to find that the productivity drops down a lot. Now, if there's any AngularJS developers in the room, you might be like, well, I don't agree with this. And I think that the truth is, if you are really productive in Angular, that's awesome. But there is a major difference between Angular and Ember. And I think that this was illustrated really well recently by Yehuda Katz, in that the main, I think, philosophical difference between Ember and Angular on that end of the spectrum is that Ember comes with more guardrails. And the idea of guardrails is that in the majority of applications, we think that we don't want you to veer off the road. We want you to stay on this kind of path. And in Angular is really well suited to a developer who likes kind of building their own conventions in their own company. So if you're that kind of developer, you might actually find a lot more success with Angular. Because it'll let you do things like inject an ORM into a directive. Not an ORM, but you can inject something like a service into a directive, which is a really, really weird thing to do. Because they give you this power of dependency injection, but it allows you to, I think, more easily shoot yourself in the foot. Now, having said that, if you're a good developer and you work at a good company, you can establish your own guardrails, and you can be like, this is how we do things, and if you all stick to it, that's awesome. The difference is that Ember makes it harder, and I think this frustrates people in the beginning because maybe they're constantly hitting the guardrail. But once you actually do learn it, it actually makes your project a lot more standard. So one question I often ask people is, let's say if you work at an Angular shop, like, are you confident that if you switched and went to another company and you opened up their code base, you would know where everything goes? And usually the answer I get is no, because people tend to do things their own way. Again, it probably sounds a bit more like I'm judging than I am, but the truth is that, like, if that appeals to you, that's awesome. But Ember, you're much more likely to go to another company and find things exactly the same way. So what did Discourse learn from this in particular? Well, this is actually Discourses Stack right here. I think this covers just about everything. We use Postgres as the database. We use Redis as like a key value store, but also for our message queue. We use it for things like flood detection and awesome things like that. We use Rails on the server side, Ember I mentioned, Sidekick as our message queue, and then JavaScript and Ruby. And this is actually that's a lot of stuff to learn. I mean, if you're a new developer who wants to come onto Discourse and add a new feature, it's possible that you will touch, not necessarily, but you will touch many of these technologies. And in terms of ease of use or like reducing your barriers to entry, that actually seems a bit complicated. And while I don't love it, I think that each one of these technologies that we use enables us to do something better and enables our product to be better. So if you look at other forum software like PHP, they're very afraid of adopting a more complicated stack because they have to make it super easy to install on a cPanel or whatever you're using. But I think that Ember taught us that it's OK to introduce more complexity if you get a benefit. And this is something that's difficult to do as a developer. So I'm going to add a caveat that that doesn't mean just make things more complex, because I'm sure we've all encountered things that are overly complex. But it's important to add complexity when it gives you a benefit. So I want to talk about the future. And I'll start by talking about the past. At the top here is one of the oldest message boards on the internet. And that's a screenshot of it in 1999. We went to the Internet Archive to get that. And at the bottom there, you can see the exact same forum in 2014. And I don't know about you guys. You can see they've changed the styling around a little bit. But to me, they largely look the same. And it's kind of interesting to think that the typical web forum hasn't actually changed much in 15 years. And if you think about other software you use on the web, can you think of any single thing that you use that has not changed in 15 years, like radically? It's kind of ridiculous. So even though forums make up a large percentage of web communication, they really haven't evolved that much. So when we started Discourse, we wanted to make sure that we were actually not just building something that would look the same 15 years from now, but that would evolve. So one reason we picked Ember is Ember advertises itself as a framework for creating ambitious web applications. And I think it's really hard to summarize. Like, you can actually see there, it has the file size listed. It's 71K gzipped. It's hard to summarize 71K of code in one sentence. But I think what Ember is trying to do is it provides structure and provides productivity tools so that you can create these more complex things. And sometimes I talk to developers who are really keen on server-side rendering. For example, at Basecamp, they do a lot of this. They use turbolinks, and they render everything on the server side, and then they use sprinkles of JavaScript, as they call it. And they're like, well, this works really well. Why would I want to use a lot of JavaScript in the front end? Why would I want to have such a complicated structure? Aren't I creating things twice, the server side and the client side? But I actually think that those people are holding themselves back, because they're thinking of a web application in terms of what the web applications you're building today look like. They're not thinking like, well, what applications could I build if I didn't have to rely on server-side rendering for everything? So like, the example I often give is like, how would you, if you wanted to build Office in a web browser, or Photoshop in a web browser, or these kind of things, if you want to push the boundaries of what web applications are doing, you should think of them in terms of the past. So Ember does this. Ember looks forward in a lot of ways, not just like betting on running a lot of JavaScript, like a heavy ball of JavaScript you get in the beginning and the structure it gives you, but they're actually actively involved in the future of the web. So there's ES6 is coming out. If you were unfamiliar with ES, or ECMAScript, it is the standard that JavaScript is based on. So I think we are currently on ES5, but ES6 is the cutting edge thing. It introduces a lot of features to the language that will help people out a lot. One of these in particular is the module system. So if you follow any kind of server-side JavaScript stuff, you might see that they have a holy war akin to Vim and Emacs with how they require modules. They have AMD, they have CommonJS, they have Require.js, they have all these different ways of doing essentially the same thing, and crazy arguments as to how to do it. In the Node world, they've settled on different things than what the browser world does, even though they're using the same language, and it's really complicated. So in ES6, they've established a way of doing modules that is very elegant, and they have pretty much everyone on board, and Yehuda Katz sits on this as well. So one thing that Ember has done is they've bet hard on this. They've said, we want Ember's code base to use this kind of module syntax. And they've actually converted all of Ember over to it already. But not only that, is that they recommend, if you're building a new Ember application, to use ES6 as kind of the community standard way of doing things. I mean, you don't have to. Discourse doesn't yet, because we have a lot of code that we have to convert. But if you download their typical project structure, which is called Ember App Kit, you'll see that it has things laid out in a way that ES6 is the ES6 style of modules. Now, the interesting thing about this is that ES6 isn't supported in browsers right now. So if you just spat out a ball of code that has all this ES6, you would get errors in just about everything. So what they do is they have a very clever solution, is that on the server side, they transpile it. And they use Grunt and a lot of awesome tools to do this. And so what that means is like akin to CoffeeScript being compiled into JavaScript, you compile the future of JavaScript into present-day working JavaScript. It makes the code a little longer, but the awesome thing is that you can try out these features today, even though they're not ready. And then when browsers finally do get ready, in theory, you could turn off the transpilation, and everything would just work. The other thing I want to talk about is how Ember uses asynchronous JavaScript. AJAX is a big thing. I think ever since Gmail came out and this term was coined, people are coding more and more asynchronous communication. So typically, this involves doing like a jQuery AJAX call with a callback. Node structure in particular on the server side is a callback with an error and something that you want to execute. But the problem with this is that asynchronous code just like this, I think, diagram is a little weird to look at, because is that an upside down J? I don't even know what that is. But it's like, it's hard to follow. And the more asynchronous code you have, generally the more functions you end up nesting, and it becomes really hard to follow. So one thing Ember has bet on is the promises spec. So this is, if you haven't heard of this is the promises A+. I think there was promises A. I think it started promises A, promises A+. But they're finally in a place that they think that this spec is in good shape. And Ember uses this through and through. So Ember's router is actually an asynchronous router. And that sounds a little confusing, because when you think about what is a router's job is to take a URL and convert that into some kind of state in the application. And conversely, I think that the URL should always be the current deserialized state of your application. So if you're looking at a user's page, for example, the router should be able to translate user/eviltrout into that view. But generally, when you're building a JavaScript application, or even on the server side, you need to get that data from somewhere. So what they've done with Ember is through and through, from end to end, the router is asynchronous, so that it expects that when you go to a route, you will need some data. And if that data is in the form of a promise object, it'll actually pause the routing until that promise is resolved. And once that promise is resolved, it'll go to the next step. And then you can do awesome things with the promise. You can pass it on to other things. You can cancel it. You can do really cool structures. So they bet hard on this. There's actually a micro library called rsvp.js that Ember includes. And you can expose that for yourself and use promises right away. But also, you can use it to wrap promises from something like jQuery, which aren't always fully spec compliant. But they have really embraced this specification. Finally, the last way that I think Ember embraces the future is the Extensible Web Manifesto. And this spec is, when I first read it, I found it a little difficult to get through. So I apologize if I can't explain it fully properly. But the idea here is that in the past, it's taken too long for features to get adopted as standard in browsers. So there's this idea that a standards organization sits down in a room with a lot of coffee, and they say, okay, this is how this new feature of the web is going to work. We're all going to sit down, and we're going to discuss it, and we're going to figure it out. Big design in advance, and then the browsers are slowly going to adopt it. And then once they've all been adopted to the point that developers feel good using it, they can start using those features. But there's actually a huge problem with this, is that often what happens is those people in a room don't always see everything that could go wrong. And I think that a lot of problems come out in specifications or ambiguities once people start putting them into browsers and using them. I think jQuery in many ways exists because of the failure of the web standards in the past. Because what you want is a standard way to do something, but there's all these little browser hacks you had to make in the past just to make sure that everything worked. So the Extensible Web Manifesto is the idea that we should bet on a smaller feedback loop. What we should have browser vendors do is expose low-level APIs, and then we should have, in the JavaScript world, people be able to build more complex APIs on top of those, and enable us to iterate using JavaScript. And the idea of this is that if we're not sure how an API should work, like promises, we can start prototyping today, and people can start using it and use the first version of promises, even though it's not standard. And then eventually, the browser vendors will adopt that JavaScript API as the standard native way of doing it. So with promises, they've actually done this. And one of the latest Chromes, you can actually, I don't know if you have to enable a feature flag, but they have native promise support. Super cool. So what started out as a JavaScript library is now natively supported and is much more performant. So how does this apply to Discourse again? What did we learn from this? What did we learn from using Ember and their focus on the future? Well, I think, like I showed with our stack, we like betting on new things, but we've taken it even further. We had day one support for Rails 4, which I was really proud of. People did a lot of hard work on making sure that our app dual booted in Rails 3 and Rails 4. We also had support for Ruby 2, day one. And Ruby 2.1 came out recently. There were some memory issues. Our other co-founder, Sam Saffron, he's been doing excellent work with Ruby and profiling and performance. And he was aware of them in advance, and he already knew our performance profiles. So we were ready for that. And then we also did things like we bet on Docker. I think there's a Docker talk today. It's an awesome piece of software. And because one thing I showed you earlier about our stack is complicated, so deployment is complicated, but Docker does a really good job of building these little containers that make it easy. So the easiest way to deploy a Discourse forum today is using Docker. And I'm really happy that we bet on that, even though it's not version 1.0. So I mentioned earlier Jeff Atwood, co-founder. He has what is known as Atwood's law, if you've ever heard of it. And it's essentially that, I believe that it says, if it can be built in JavaScript, it will be. And we knew day one that this JavaScript is just going to become bigger. It is essentially the runtime for the web. And we knew that when we were building this software that we wanted to bet really hard on that. So in a way, using Ember was a bet on the future. In a way, going big JavaScript was a bet on the future. Because there's many people who still think that you shouldn't build applications this way. I think it's allowed us to do a lot of things that we couldn't normally do, like infinite scrolling and editing in place and all these really crazy things. But ultimately, it is still a bet. And it's like, you don't always know which way technology is going to go. But you shouldn't be afraid to bet on the future in the case where you know that you have a good backup plan or that you can structure your application in a way that suits you. So if there's one thing I wanted to take away from this talk is that, yeah, learning can be hard. I don't know if you remember learning to ride a bike, but I do. And I fell over a bunch of times, and it hurt and sucked really badly. But when I was able to learn a bike, it became awesome. It became liberating. Riding a bike is one of the most fun things you can do. And like as a kid, you can really get around your neighborhood and have a fun time. And I think if you approached the if you approached riding a bike the way many people approach using new pieces of software, you might never have taken the risk. You might have never bothered to learn something because you're like, well, if I sat on a bike and I fell over right away, so what's the point of learning this, you know? Take the time to learn things. I think you will be a better developer. And yeah, I think that's everything. So I was hoping that people might have questions. I kind of glossed over many ways the specifics of Ember and the technical side and stuff like that, as well as Discourse. So if you guys have any questions about that, feel free to ask or anything else. Do we have the mic?
So you talked about some of the benefits of using a front-end framework versus server-side rendering, and one of the main benefits you talked about was programming for the future. Mm-hmm. Can you talk about other benefits that may be benefits to the developer themselves or benefit to a team? Because that's what most of us think about every day, not necessarily the future.
Okay, so well, the benefits, okay, rather than doing a server-side traditional application. I think, well, personally as a developer, I like building things that excite me and are fun and that I can not necessarily show off, because you don't want to make something just because it's pretty, but you want to make something that works well and enables people to do things. So maybe a good example of an application would be like Google Maps. Google Maps is something that would be impossible with 100% server-side rendering. Actually, it's not impossible because it did exist. It was called MapQuest, and it was a piece of flaming garbage, if you pardon my language. I think when Google came out and were like, we can build, look what we can do if we use JavaScript to move around images and unload things and stuff like that. And almost immediately people were like, well, why would I ever go back to MapQuest and server-side rendering? So, but building the Google Maps one was also a lot more complicated. So you're like, I understand. Like if you're given a domain and a simple problem to solve and not much time, it might be a hard sell to your client or your boss or whoever it is to say like, I want to build this thing that is really dynamic and that has and enables me to do things that I couldn't normally do, like animations and fancy JavaScript things, perhaps 3D canvas stuff. Yeah, that's a good concern. So I think my answer is that as a developer, it enables you to make more fun products, and that's what to me is awesome about being a developer. Any other questions? Cool. Oh. Let's see.
How do you approach testing when you use Ember and Rails together, specifically like integration testing? Because they seem like two different worlds. So,
right.
If you're, making a call to submit a new post or something like that, you need to ensure that not only does Ember work, but the server side, the Rails side also works.
Right. So there's actually different philosophies of how to do this. I can tell you how Discourse does it and how I think is a good way to do it. I don't believe in generally in full end-to-end testing, in that terms of integration, whereas you have the JavaScript application that makes a post to the Ruby application, and you're testing that transit worked and that the server responded and did what it should. So we actually have two test suites, which is pretty common. So our Ruby application or a Rails application can be thought of as an API. And that's essentially all it is. It's a JSON API that responds to requests. And if you were developing an API for other people to use, it's actually not very hard. The way you test such a thing it's not a fully solved problem, but it's understood how you can do it. So in Discourse, we treat the Rails side like that, where we use RSpec and we have a pretty comprehensive test suite that tests all our controllers, which I guess is the Rails version of integration. We test our models for unit tests and stuff like that. And then, so we essentially test that entire domain, make sure that we respond to requests, that you have API keys, and all that works. Then we have the Ember side, where we have a QUnit test suite. And for that, we've divided it up into unit tests and integration tests. So Ember now has an Ember testing framework, which is really cool. And it gives you an asynchronous API to say, when I click on this, this should happen. And this should appear. Or visit this URL and then click this button and then visit this URL and make sure that this thing happened. So we have a bunch of tests that look like that. And the cool thing about when you run that as a test runner is you can actually see the browser. I don't have it on this computer because unfortunately my computer couldn't hook up. But it's really cool because you can actually see the app running in a little minimized corner of your screen as the tests are going by. So the way we do that without fully contacting the server is that we stub requests. We use fixtures. So when an AJAX request goes across to the server, we actually just have a directory that has the standard JSON responses for those, and then just fills it in. So the test suite can run totally independently of the server. So philosophically, you believe that you have to test the app totally end-to-end. I respect that. People do Selenium-style things, but it's not how we've set it up.
To follow up on that, when you're updating when the API changes, how do you go about updating those fixtures for those tests?
We have a rake script that we can just run, and it'll so we have a development image of the server that most developers use with a development database, and there's a rake test you can just run, and it updates all the fixtures. They don't actually change as much as you'd think. I think maybe it's because we're approaching version 1.0 and stuff like that. So at this point, most of the time when you're adding a new feature, most of the application just works pretty well. But you can run that at any given time. I like that you guys are all so close. You could just pass the...
Works pretty well. So I was curious about what changed over time with your infrastructure, being that you're going more client-side rendering of the UI, which means that a lot of what's in Ruby on Rails you don't need anymore. Right. Did you find that you actually moved away from using a complex framework like Ruby on Rails to go to Sinatra or something else instead?
No. Well, I have this joking theory about Sinatra that every developer I know that's we're going to build our app in Sinatra eventually makes it into Rails anyway, because they add active support and then they're well, we need an ORM and we add this, and at that point you've essentially done that. Now that's a bit of a troll because I know that that's not totally true. But yeah, the major thing we don't do is rendering, but even that's not strictly true because we do render emails, for example, and we render some essentially no script content so that Discourse can be crawled by search engines. So we render really trivial versions of some of our pages just so that they can be sniffed. So we do end up using almost all of Rails. There is that Rails, I forget what it's called, but there's an API version of Rails. Maybe it's Rails API actually, which is designed just for people like that in that use case where they're it's Rails but without all that stuff you don't need. But for us, we found that we actually do need most of it, some more than others, though. So that hasn't really applied to us. But the cool thing is if you're building, a front-end MVC project, is that you don't have to use one server-side language, right? You can use many or whatever suits you. There's a lot of people doing Node with Ember and stuff.
Yeah, we used to use Spring MVC a lot on the Java side, and then we switched over to doing more. If you're doing single-page applications where you don't need to worry about HTML that would be seen by like Google, then a single page application with no server-side HTML generation is fine.
Yeah.
But we went to what's called Drop Wizard in Java, which is basically for RESTful APIs. So it kind of gets rid of a lot of the dependencies on server-side rendering of HTML, but you still get the ability to render or just reference different Maven dependencies that get you other things you need.
Yeah, that sounds cool.
Same idea.
It's awesome to sometimes realize you don't need it anymore. Let's strip that whole thing out.
Or you just realize that your backend is no longer just one huge server and you have a distributed architecture of multiple things that are focused on what they need to do. So
yeah, because if you're not doing rendering most of the time, why is that server built to support that as well? Why not shove that over somewhere else that can do that better? I agree. Anyone else? Cool. Well, thanks so much for coming. I think we got a little bit out early, but hey, it's lunchtime soon, so it'd be good to have a nice, slightly longer break. But yeah, thanks for coming, guys.